Stream as well. So my name is Sanjay Upal, formerly known as the CEO of VeloCloud, now one of the VPs here in VMware. And I'm as new to this building and where the coffee is and all that as you folks are. So it's been about a month since the acquisition. Part of my team is over here. We're still all housed as one unit at at the place that some of you saw last time, which is in Mountain View. And about 6 to 8 weeks, we're going to be moving the entire unit here to VMware in one of the buildings on the other side of campus. And that means that VeloCloud continues. We just changed our title from VeloCloud, the company, to VeloCloud by VMware. As you know, a while ago, Bob Dylan said you've got to serve somebody. So we're kind of changing hats from that standpoint, serving other people. But one thing doesn't change. We still bow to the networking gods. So we're still doing pretty much what we were doing before. We have some very exciting enhancements to talk about. And I want to briefly mention those before I introduce some of the people in my team. So what we're doing first is we are expanding what we've done from running services in our cloud-delivered SD-WAN. So Rachna is going to come up and talk about a couple of those. PCI as a service, very important. And then the concept of gateway federation. As you know, service providers are a very important route to market for us because they buy the infrastructure and they convert it into a service, and how these service providers federate their gateways, because we have gateways that are running in the infra. Then we have 3 demos for you. And so this is Rachna. The first demo, we're going to talk about something that we've been working on for a while, which is now add services to our cloud-delivered SD-WAN. And one of the first services we're going to show you is a security service, which is a Palo Alto VNF that is running on our infrastructure, and how that can be chained together for the clients that are out there to get access to security services along with the SD-WAN service. Okay, so we're going to do that, and Nitin's going to talk about that. The next thing we're going to show you is segmentation. Now, of course, there's a lot of talk about segmentation in SD-WAN. We think we've done a couple of very special things here, which is how to tie in segmentation at a deeper level, how you can do topology insertion, and Fan's going to come on and talk about that. Where's Fan? Fan's back there. And then the third part is Rohan's going to show you a demo about how we can do route influencing on the UI. So all of this is in keeping with the roadmap and the project plan that at least some of you saw the last time we did the NFD. What we're going to not spend too much time talking about is how VeloCloud is integrating with other parts of VMware, in particular NSX, but there's some pretty exciting stuff that we want to reserve some of it for the next time. So with that, I wanted to pass the baton over to Rachna. And once again, welcome to VeloCloud by VMware.
Congratulations.
Thank you, Sanjay.
Congratulations, by the way.
Oh, thank you. Thanks.
Can you guys hear me okay?
Yes.
Hello, everyone, and welcome everyone on the live stream. I'm Rachna Srivastava, and I'm a product marketing manager here at VeloCloud by VMware. So what I'm going to talk about is, first off, just a quick introduction. Of some of you in the audience very familiar with what we do, but for the benefit of the folks on our live stream, just a quick introduction on what VeloCloud SD-WAN is. So VeloCloud SD-WAN basically is an overlay solution that kind of brings together elements of private networking as well as the internet for the enterprise to kind of create a solution that helps optimize the WAN links. And there's components of our SD-WAN solution that throughout the presentation you will see, and even on our demos, we will touch upon. So let's start off with, for example, our edge. The VeloCloud Edge is available both as a hardware or as a virtual edge in both form factors that can be used. And this is something that goes in a branch, or it can also be deployed at the hub location. And these edges, one of the relevant or important points about these edges are that you can easily achieve a zero-touch deployment with these edges. So very simply, these are shipped over to the remote locations. Without really having a very a technical expertise, you can actually connect these edges to the links that are available. And whether it's a single link or a dual link, the edge is then able to call home and then basically get their configuration pushed down to them, or they can, as well as path updates and things like that. So basically, they're able to get set up without really much of manual intervention or a lot of technical expertise. So that allows for the ability to bring multiple edges up in a relatively short time with relatively less effort. Now, the other part is our orchestrator. Now, the VeloCloud orchestrator is a monitoring and management portal. And this is cloud-based as well as it's multi-tenant. So we serve both our enterprise customers, and we have a huge presence in the service provider space. And multi-tenancy is something that is very, very relevant to our business. So orchestrators help achieve both a service provider as well as an enterprise use case, and that is basically something that's cloud-based. Now, you can have, once you have an edge up and running, it can either connect to a hub, which is an enterprise data center, and you can have a hub, or the other option is to actually have a hubless environment, in which case we're actually leveraging our cloud gateways. The third component of our solution are these cloud gateways that are strategically placed worldwide in the internet. And basically, these gateways are multi-tenant as well and give the ability for internet connectivity to SaaS applications or even back to the data center. Both of these connectivity can be secure and reliable with a bunch of technologies that we'll talk about, but basically leveraging the gateways. So 3 main components of our SD-WAN solution. Now, as we are building and designing and evolving our products, there's 3 key pillars that are very, very important as we think about what features we build in, what we develop, and what we put into our products. And these 3 key pillars are abstraction and automation, contextual implementation, and self-learning and adaptation. So let's talk about the first one, which is abstraction and automation. So very simply, the goal is how can we elevate IT? How can we really simplify configuration? And how do we really make the lives of network administrators easy? And this is done by abstracting configurations, by providing very simple UIs to manage configurations. Now, there's a lot of vendors out there, there's a lot of competitors who will actually just provide GUI-based templates. So you can do whatever you're doing in CLI, but you're doing it in a template form. And it still takes a very long time if you're clicking through things. You have to have a lot of knowledge to basically able to figure out what you're trying to do. It takes a lot of time. It can be error-prone. What we are doing is we're really taking a different approach by building in a UI that's more sensible and that's more intuitive. So for example, the outcome might be, these are the applications I want to prioritize. I want to prioritize voice, video, and let's say access to Office 365. Everything else I want to leave as best effort. So as we're building out our policies and templates, what we're trying to do is just state in our policy, in the orchestrator, this is what we're doing. The rest of the configuration is going to be automatically deployed to our devices that are part of the enterprise in SD-WAN. So that's the main difference here, which is a very simple UI that's intuitive and sensible, and it makes sense and is abstracted. The second piece is contextual implementation. This is another interesting concept because, again, we can have multiple templates that we're deploying enterprise-wide. But the real value here is if we get an enterprise-wide template and we're deploying them across edges and hubs in the network, how do we make sure that each of the edges are really figuring out what's relevant and then really deploying the configurations that are relevant to the environment? And as an example, let's say we are setting up a QoS policy. And you would have a QoS policy on the edge, and then you would have a corresponding QoS policy on the hub side. Now, if the hub is serving multiple edges, you would need corresponding QoS policies both on the hub and the edge. And that could be over thousands of devices, a lot of QoS policies. Now, the way we manage it is the hub will actually be smart enough to understand if we have certain applications prioritized at the edge and the hub is sending traffic to the edge, it will automatically adjust its configuration so that it gives priority to those applications. This is not something you're programming manually. This is something that the hub is talking to the edge, figuring out, okay, these applications are a priority. I'm going to give priority to these and change its configuration accordingly. So that's what we mean by keeping context. And the goal here is, again, simplicity. You don't have to configure every single device to achieve an outcome. You can just simply state the outcome. And the third very relevant part is self-learning and adaptation. So how do we really look at other conditions outside of VeloCloud SD-WAN devices? For example, how do we look at other links and what they're doing? Or how do we really look at our neighboring routers, for example? How do we learn from them and make changes as we go along. So there's a couple of examples that we'll talk about, but these are sort of the three key pillars that we're basing everything on. So as we dig deeper, what you'll see is there's about 6 features that really make up our key pillars. And we will touch upon some of them in demos, and some of them I'll highlight. But basically, application performance, which is our DMPO technology, which is dynamic multipath optimization. The ability to create automated, simple VPNs. Segmentation, which we're going to spend a lot of time in terms of even demo and explaining how that works. Routing, again, there's a demo that you will be seeing. Service insertion, again, Sanjay talked about it a little bit, but this is essentially how can we run multiple services in a distributed fashion, particularly at the branch, at the VeloCloud edge device, particularly running services as a VNF. And the last is zero-touch operations. We've talked about that in the past, and I talked about it a little bit. But those are sort of our key technologies that enable our outcome-driven approach. Now, quickly, let's touch upon dynamic multipath optimization. Also, this is assured application performance. And again, some of you may be familiar with this. We've talked about it in the past, but just to kind of explain you again here, essentially, there's 3 components to dynamic multipath optimization. The first one is continuous link monitoring. So whether we have, we are transport agnostic. So whether we have wired links, wireless links, public links, et cetera, we are basically going to monitor every link in an automatic fashion, and we're checking for the quality of the link, the condition of the link. And then we have the ability to actually do some per-packet steering. Because we are flow-based, we can actually do things mid-flow. So we can actually check, we can look for packets, and we can steer packets as needed. So for example, if there is we detect a brownout, if there is a link that is an error or we're having problems, we're able to steer links mid-flow and per packet. So I correct myself, we're checking for packet flow. And so as things, if there are some brownouts, we'll actually fix itself. And then we'll go ahead and enable the steering. And the third is on-demand remediation. So we're checking for links, and we're checking for link conditions. And if we notice that there are any issues, we'll actually remediate. And this is even relevant if you have a single link. And based on priority of the applications, if you have set a policy where there's an application priority, let's say you want to prioritize voice traffic, we will check for the link, we'll do some forward error correction, jitter correction, jitter loss correction, et cetera. So that's this example actually here, what we have is from a real customer, where we have the customer started off with a single link, an MPLS link, that was having issues. And so they brought in SD-WAN because they were having trouble with their voice traffic. So we introduced actually a commodity broadband, which is a cable in this case. And what we found is, even with the cable link, of course, the quality was not as good. So as we introduced SD-WAN, we did some link corrections and remediation. And then we were able to get a very good quality of voice. So basically, this is end-to-end, you're getting the DMPO working.
I mean, you said you did link correction and remediation. What's that mean?
So we actually will, as we're monitoring the packets, we're actually making sure to make sure the quality is good, we will do some forward error corrections. We will check for the link, and we will remediate the links as we go.
So if you have packet loss, we can enable forward error correction. If you have jitter, we can remediate the jitter conditions as well. We can add jitter buffering. So it's on demand, we can decide what technology needs to be applied for a specific application, and we can do more of a link conditioning. So more than remediation, think of it as link conditioning. It will look as if the condition didn't exist. So we call it link conditioning.
Can you talk a little bit more about how you do that?
Yeah, sure. So for instance, example is Skype voice and Microsoft Link. So Skype for business voice.
Right.
So if a consumer is starting a Skype transfer, which is not important, and if Skype for business is important, so we look at the application first, because there is only limited bandwidth. So when we do things like forward error correction, we will duplicate the packets on a single link, but we don't want to duplicate it for every single application. So on demand, we will look at the link condition. We'll decide, oh, by the way, there is 3% loss, but someone is doing a consumer Skype, that's not important. So we will not do the FEC for it. But if somebody is doing Skype for business, we will enable forward error correction for that application.
And how do you identify those? Because presumably those are encrypted, right? How are you ascertaining that this traffic is a priority? Is that a user tunable setting, or are you dynamically learning these things based on DNS queries? Or?
Yeah, so right now we can identify, there are multiple techniques that we have. So one is like the deep application recognition.
Okay.
So as a part of deep application recognition, even including the SSL sorts and all, we can see that this is the app. For instance, Skype, we can break it down even further, right? Whether it's Skype file transfer, whether it's a receive, transmit, we can go to that depth. So we nearly identify close to 2,500 apps. We also have a pre-populated list of database in which there are these well-known apps, SaaS apps that we pre-populate. And in addition to that, what we also do is, since DPI takes several packets, we kind of cache the results. So next time if the same flow comes in, we can immediately react to it because we already know that this particular session, this particular flow was a high priority session. So we don't need to do that DPI again. So it gives you both performance benefits, but also it lets you take that decision on the very first packet.
Okay.
How do you know which app is the priority?
Yeah.
The user.
So it's,
You're going to say that. So the user can just set the, we recognize the applications and the user can tune what's priority. But we have defaults for usually what is priority and not priority for a business.
Okay. So you've got a set of canned defaults that you know are, priority, not priority. Your app ID, whatever the terminology is for it. You ascertain that. Oh, I'm just trying to work through a workflow in my head. First couple packets, identify what it is, determines based on this default set, and then it sets the priority and adjusts accordingly otherwise. And if it's an unknown application, then it will attempt to teach itself, essentially, record what it is. And then is that a user tunable or?
so we support custom application maps.
Okay.
So in which case user can also add custom apps to the profile as well. So it is user tunable.
Excellent.
Yeah.
Thank you.
Then actually, just before you move on, the other thing I wanted to touch on is the per packet steering.
Right.
Is that just on the local WAN access link, or I would assume, right? I mean, I don't know how else you would.
So the per packet steering will be for both the internet links as well as private link, MPLS link.
Sure, but I mean, that's just happening locally. So if you have like two internet connections, say locally, you're going to choose
At the edge.
one, just
Yeah.
one of those two, right?
Exactly.
Well, we can also actually aggregate capacity between the different, so we can actually steer packets. So for our bulk file transfer, we can spray those across multiple links, and that's even taking into account varying latencies and varying jitter conditions on those links. So the DMPO technique is a back-end technique, so we actually remediate the streams at the receiving end, and we reconstitute the original packet flow.
Thanks.
VeloCloud's one of the few to handle fat elephant flows.
Yeah.
If you have a fat elephant flow, most of them can only steer it onto one link or the other. Our VeloCloud can steer onto two. And they can also switch the flow. Some companies can only, if a packet or if a link drops or you have a brownout, they'll continue to put that flow down there until it dies. That's fine for HTTP, not so great for long-held sustained elephant flows. So VeloCloud has a competitive edge in that specific feature.
That's why I coined it out per packet. Okay,
Correct. So I
makes sense.
think the thing important to point out here is that we maintain session persistency, even during flipovers of flows to different links.
I have one question that is also meeting that, yeah. So now you have internet links, MPLS links, maybe they have different MTUs. How do you handle that?
So the MTU is handled in the overlay tunnels, basically. So the underlay is still able to fragment, and we're going to, again, reconstitute the original flow at the receiving end. So there's basically a virtual MTU across the overlay.
Okay, so you can actually transport bigger MTUs than they actually link and provide.
Well, given that we're primarily doing hybrid deployments, we take the lowest common denominator, so our MTUs are typically gravitating to 1,500, because that's the usual internet MTUs.
Okay.
But we do have eMTU support, so we can dynamically adjust.
Okay.
The path MTU functionality with TCP. We support that as a part of the protocol, so we can adjust to that.
So you can virtualize, say, I can transport a bigger MTU,
Yeah.
then put the packet into smaller chunks and
Yeah.
transport it and reassemble it on the other
Exactly.
side.
Yeah. Because
So
it's
if somebody really needs jumbo packets over one, let's say, 1,500 MTU link, you can do it, yeah?
correct. And we see that quite common, right? With multicast and all these different apps, we have to adjust to it. So it's a very common thing. Like we can fragment it, we can handle fragmentation as well. So there are like multiple scenarios, but path MTU functionality where you can adjust the MSS is also something we support for TCP.
So you're doing the MTU and MSS, so MTU would be meeting also UDP, or you're doing this only for TCP with MSS?
That's primarily for TCP.
Okay,
with MSS.
okay, thank you.
Okay, so the next new capability that I wanted to talk about is our PCI as a service. So basically, we are the first and the only vendor in the industry to offer PCI certified SD-WAN service. So we are PCI DSS 3.2 certified. Now, what that means is retailers, a good chunk of our customer base is our retailers. And PCI audit, going through that process is a very important process for them. So retailers actually are able to move through their PCI audit process in a much faster and efficient manner if they leverage our service. So they actually benefit from the fact that certain components that we have are already PCI certified. Now, all of our components are PCI compliant, but certain components are actually certified, which means that if the retailer has 5, 10, or 15 different components to worry about for certification, by leveraging our service, it's a few less components to worry about. So that's something that's unique and something that our retailers find really beneficial. Now, we work with a company called Coalfire to actually go through the certification process. So we've included an AOC summary, which is attestation of compliance. All of the different checks and processes that we went through have been included here. And both on the control and the management plane, which is the orchestrator, a lot of security features that retailers would care about from a security standpoint are supported, as well as on the data plane side.
Are you able to build standard IPsec tunnels, or are your tunnels only between VeloCloud instances?
No, we support standard IPsec.
Okay.
Yeah.
So we have certain use cases where, let's say it's a hubless design, or let's say you're trying to connect into AWS or Azure. And so from, let's say, where the gateway is to Azure or to AWS or to SaaS, we would actually typically create an IPsec tunnel.
So you could build an IPsec tunnel to, your VPC in AWS.
Yeah, exactly. So you can build IPsec tunnel from the gateway. There have been scenarios where you need IPsec tunnel directly from the edge as well. Example like Zscaler and WebSense and some of these vendors want that, so we support that as well. Plus, this is all in addition to our IPsec riding over the overlay. So that will, or with the DMPO technology.
And GRE too, if you needed it, can you do GRE, or is it just IPsec?
Correct. We support IPsec only right now.
Okay.
Yeah.
And if you're going to get to it, that's fine. But can you talk a little bit about like the key management? Had you planned to talk how you handle your?
Yeah, we don't have a slide on it, but the key management is using PKI. So what we have done is the CA server is actually built into the orchestrator itself. So you don't need yet another CA server. So when an edge comes up and it authorizes with the orchestrator will assign a unique, it'll have a certificate built in. And the key thing that we have focused on is with pre-shared key, life was really simple. It was simple to configure, but very difficult to scale. What we did is we made PKI very, very simple to consume. So on our UI, there is literally a checkbox which says whether you need PKI or not. And if you do need PKI on a per tenant basis, because it's a multi-tenant VCO, we can assign a customer ID with a CA built. The CA will assign each certificate with a customer ID built into the cert. So you don't need to install yet another Microsoft CA. It's built into the orchestrator itself.
And each appliance gets a unique certificate
exactly.
to be managed and revoked.
Absolutely. You can revoke your cert. So most of the large enterprises, like they challenged us, okay, we've been using Microsoft for a very long time, or they use a physical server on which they have the physical security. So we showed them the entire workflow, like the whole key management, including revoking the certs. Everything is made one click from an IT admin perspective. In fact, we support dynamic CRLs, like certification revoke list. So if edge is compromised, we can make sure that it is not a part of the VPN. We'll auto revoke the certs as well.
And then the last part of my presentation is gateway federation. And this essentially, the goal is to have sort of global SD-WAN that connects enterprises that are sort of global in nature, that have presence not only in one location, but multiple locations. So it's basically bringing a federation together, and Sanjay touched upon it a little bit. So an example could be if we have an enterprise that has a location in one part of the country, let's say in the United States, and they also have a regional site, let's say in another part of the world, let's say Asia. And they are working with a service provider who is their primary provider. This service provider offers SD-WAN as a managed service, and through their service, and it's already integrated into their backbone that this enterprise works with. Now this enterprise needs to get some SD-WAN connectivity with this regional site that's located in Asia. Before, they would have to either work with the service provider to have some sort of with other regional providers, and it wasn't that simple. But with federation, the way we would work is that we would enlist a partner in that region, and this partner already has gateways and edges that are in place. And basically what we're doing is we're connecting from the provider edge into this partner environment, basically able to get connectivity worldwide. So this is the true sort of meaning of federation, where you're able to bring partners, service providers, and service providers in regional locations together to kind of get global SD-WAN connectivity.
This means I could, as an enterprise, from the perspective of an enterprise customer, I could enlist an MSP's network, but make it look like it's my own by using their SD-WAN capability, VeloCloud capability.
So the advantage is this is mainly for the service providers to offer SD-WAN services. So the
that's what I was trying
provider
to,
will actually enlist the partner.
That's what I thought you were saying, but I was asking you for the reverse. This is not an enterprise product. This is a managed service provider's product, which allows them to go and extend their footprint. So
exactly,
they could go to, if there's a US telco, they want to go and get coverage in Australia. There's an MSP in Australia who's got POPs all over the place. They can do quid pro quo deals to use each other's networks, or some sort of revenue sharing or agreements. And it still looks like the original carrier is actually hauling the traffic.
And to the enterprise who's enlisting their primary service provider, they can actually get a view of all of their devices, their edges, all in one portal.
So
And that's fully tenanted, right? Like, so every customer is completely independent.
So before, if you think through it, like let's say a Telstra in Australia, they have a huge, obviously tier 1 provider in Australia. And minute they have to come out of Australia, they have to take this for the off-net. They'll have to buy expensive lease lines. And obviously they can't monetize on it. It's low margin business for them. Now what they do is they'll spin up these MSPs on our portal, because it's a 3-tier multi-tenant portal. It's not just 1 tier or 2 tiers. So on because it is 3 tiers, you can have operator, which is Telstra, have multiple MSPs under them. And each of these MSPs can have their own enterprises carved out.
Yes.
So now, based on who the enterprise is and what kind of deployment they have, they can pick who the partner should be, and they can pick a combination of their own gateways and the gateways that an MSP would want to spin. But the other important use case here is like that VeloCloud gateway. We also federate with these SPs.
Yes.
An example being Vonage serves UCaaS for us, like voice traffic. And Vonage is like, hey, you know what? I really like all this voice traffic coming to my network because that's critical. But I really don't want all this VPN traffic. And you, VeloCloud, you have a worldwide VPN footprint. Can we federate with you? So this federation is an extension where we say, yes, you can federate with VeloCloud hosted gateways. You can have your own apps. And with that, we can build one network. So it's like really a chain reaction. More of the SPs who deploy it, they work with each other. They work with VeloCloud. There are all sorts of use cases.
And that's still PCI compliant?
Yes. Yep.
No.
So the PCI piece is the VCO and the controllers are hosted in a PCI environment. So our ops team goes through it, the whole process.
Yep.
The partner gateways itself, it's the responsibility of the SP because we don't own it. We don't own that network. So
Yep.
PCI has this whole responsibility matrix wherein we carve out what is our responsibility as VeloCloud and what is your responsibility as an operator
The
or
thing is, if the
enterprise.
service provider is providing substandard, you'll just route past it.
Yeah.
The thing about the SD-WAN is you can cut a deal with a company, and if they screw you over, you can just cut them out and stop paying them for the service, or you can point to it and say, this is not, you're not holding up your end of the deal if they choose to deprioritize third-party traffic.
Yeah.
Does that mean, now one of the challenges here, of course, is that historically we've seen companies focus on service providers, go all weird about service providers and pretend that they're service providers and only produce products that service providers would buy, whereas enterprise networking companies tend to have a different, more flexible, more creative viewpoint and a different sort of, service providers like to think that their networks aren't the same as everybody else's. But this implies that you're seeing the network, the WAN market is just one market, and it doesn't really matter whether you are. Are you service provider focused? Are you enterprise focused?
We are both, for sure. I mean, we have large enterprises who will host all of this by themselves, and they want a completely transport agnostic network, and they'll have a branch, they'll have a hub, they'll have a controller, more traditional style. There are end customers who fall somewhere in middle, which I call it as fully on-premise, right?
Yeah.
There are customers, most of them are hybrid, which will say, hey, you know what, all the VPN traffic and all, I want it all on-premise on my network. It is okay to do more of the cloud management piece of it, and the controller is in the cloud, but all the data is on-premise. And then the other extreme is where you will see, okay, I want to even send the SaaS traffic and IaaS traffic and all other traffic to your gateway or a partner gateway.
And what happens when we start getting recursion where an enterprise might start be rolling over the top of somebody else's VeloCloud network? So let's say I'm an enterprise and then all of a sudden Telstra's using SD-WAN extension into the Philippines and I'm running my VeloCloud on top of their VeloCloud, which might be running on top of someone else's. At that level of recursion, we're getting into some pretty...
Well, we have those use cases actually even today. So we have like a large insurance company who has a lot of VeloCloud sites deployed as a full over the top.
Yeah.
And now the SP is coming in because it's like close to 20,000 sites. So it is all VeloCloud, even by SP's positioning VeloCloud, even their own IT has deployed VeloCloud. So it looks like two islands of VeloCloud in a way, but it's all bridged together end of the day.
But you're not encapsulating.
No.
You're just...
Yeah, we just treat it as islands in that case.
So it becomes a billing problem.
Exactly, yeah.
Yeah.
But we have these use cases for sure, yeah.
Did somebody ever ask you as an enterprise with these functions, you could also start, let's say, offer transport services to somebody else, yeah?
Yeah, we don't want to compete with SP, so we will not get into like offering the last mile transport itself. So we want to have the transport agnostic approach. So it's a network as a service. We can give you components which are hosted, and then obviously you need your partner or a SP who can give you the transport.
Okay.
Yeah. So.
But your example was your insurance company with these many brands. They have maybe a subcontractor which is only present in 5 of the locations. They could offer them a virtual network which they can use across their infrastructure.
Yeah.
That's a smart play. I mean, the last mile is the most expensive bit. That's the most complicated. So.
Yeah, and I think you brought up the PCI as well. One thing to mention about PCI is that it is mostly about accelerating PCI, right? So PCI is obviously not new. One customer that we worked with, they say, because this is annual process that you have to go through, it's an annual attestation of compliance. So the critical piece on PCI is customers realize like $200,000, $300,000 of saving just from PCI, because we are giving them ready to go PCI for our infra. You don't have to see who is managing it, monitoring it. We maintain it annually. So it's a true service that we are offering in the PCI world. So.